So we have a question here. This is our next example that we have, right? So the battery in the circuit diagram below has an EMF of 12 volts and an unknown internal resistance, right? Which is R here. Voltmeter 1 is connected across the battery and voltmeter 2 is connected across the switch. The resistance of the connecting wires and the ammeter is negligible, right? So now that it's written it's negligible, you know that it's supposed to be neglected because it's very small, it's significantly low, right? So write down the respective readings on the voltmeter 1 and voltmeter 2 when the switch is open, right? This is 1.1, right? When the switch is now closed, what is the reading on voltmeter 2? The voltmeter 1 changes to 9 volts. What will be the new reading on V2, right? And then calculate the internal resistance of the battery. So those are the 4 questions. So number 1, when the switch is open, there is no flow of current there, so it's just going to be what, 12 volts. So 1.1.1, V1 is equal to 12 volts and V2 is also equal to 12 volts, right? And then 1.1.2, this is the answer for 1.1.2, right? So what will be total? What is the total external resistance of the circuit? So the total external resistance of the circuit, we are supposed to get the R parallel. So R parallel is equals to 1, which is the same as 1 over R2 is equals to 1 over 12 plus 1 over 6 plus 1 over 2. Which is equals to, the R parallel is equals to 4 ohms there. So the total is going to be 4 ohms, 4 ohms plus 2 ohms, which gives us what, 6 ohms. That's the answer for our question, which is this one. This is example number 1, right? Okay, so the next one, let's look at the next question. Alright, so we have our V1, this is this one, and it's like this, and then we have a small one, bigger, small one, bigger, like that, and then we go here, and this is our ammeter, this is our 1 ohm, and this is our switch, and this is our V2, like that, and this is our 6 ohm, 6 ohms, and this is our 3 ohms, okay, like that. Okay, so what is the reading on V1, right? So the reading on V1 will be equal to 10 volts. Why? Because this is the EMF, this is written 10 volts. So the reading on E1 is always equal to the EMF voltage. And then what is the reading on E2? So E2, number 1, number 2, V2 is the same as 10 volts. Still the same as the EMF voltage. When the switch is closed, the V1 drops to 7.5. What is the reading on V2? So when the switch is closed, now we are going to close here. And what is the reading on V2? So V2 is going to read 0 volts because there's literally nothing, right? Okay, so now that we have literally nothing, calculate the reading on the ammeter. Okay, so the reading on the ammeter, how do we go about it? We first have to find the R parallel because these two circuits are in parallel. So R parallel is equals to 1 over 6 plus 1 over 30 to the power of negative 1, like that, right? So it's going to be 2 ohms, like that. So now that we have 2 ohms, the R total, the R extended, is equals to R1 plus R total, R parallel. So we are going to add this 1 ohm here to this parallel conversion. So it's going to be 1 ohm plus 2 ohms, which gives us what? 3 ohms, right? So that's the total resistance. So V is equals to IR, like that. So we want the total what? Ammeter reading. So we are looking for the current. So current is equals to voltage over the resistance. So the voltage is what? 7,5, because they say there is a drop. So it's 7,5 divided by 3 ohms, and it's going to give us 2,5 amps. So that will be our ammeter reading there. And then calculate the internal resistance of the battery. So E is equals to current and then the big R plus the small r. So current we got it as 2,5, right? And then the E is what? 10 volts, because we originally have 10 volts. So the 10 volts is going to be 2,5, 3 plus the small r. So 7,5 plus 2,5, R is equals to 10 volts. So now you're going to say 10 volts minus 7,5 volts divided by 2,5. So 2,5 volts divided by 2,5. You now get your R. So R is equals to 0.83. If you do the maths, yeah, somewhere here. So it's 2,5 times 35, right? 7,5. So 10 minus 7,5. It's going to be somewhere like that. I think, if I'm not mistaken, then R should be 1. But if I'm mistaken, then R should be 0.83. Just find out how far true that conversion is. Okay, but yes, that's the formula right there. That's the formula.